Thank you. Now to look at our solution to this problem. I said find the area. I did, of course, mean volume. Just to give you a visual representation of what was going on with that problem, what you are really doing is finding the volume of what is called a frustum. A frustum is kind of a truncated cone. So really, we're finding the volume of the, well, it's a trapezium, isn't it? That is rotated around the x-axis, and that solid is called a frustum. Okay, your work solution, here's a work solution of what you should have found. Note what I've done down here particularly. We like to keep pi in our answer because it's in exact form. Also, I don't like mixed numbers too much. I've converted that to an improper fraction. Okay, on to our next example. Our next example goes like this. Draw a sketch of, that looks strange, find the volume of the solid by rotating that about the x-axis, where x is between, that's what that means, x is an element of the numbers between 2 and 5 inclusive. That's not a coordinate. It's just saying x is between 2 and 5. Okay, well, let's get a visual representation on what's happening here first. The sketch may look complex, but it's not really. What you would need to know to solve this, or to give a visual representation at any rate, is what the square root function looks like in general. Well, in general, a square root function is going to look like that. Okay? That shape, somewhere on our number plane. Where does this one, how does this one look on our number plane? Well, a good starting point is to see what happens when x is 0. Okay? When x is 0, we have fx equaling 0 plus square root of 4, which is 2. So it has an x-intercept, a y-intercept at 2, doesn't it? So we could plot that point as a beginning point. So let's do that right now. I'm going to fix up that. Right, okay. So x is 2. And we know that it's going to be of the shape I showed you before. So all we need to know is that what we're doing is rotating a line like that about the x-axis. And we could be talking about that sort of situation. This is just a working sketch. I don't need a fully labelled diagram really. But just to show you, this is what we're up for. We're trying to rotate that around the x-axis, so we could end up with something like a fruit bowl or something like that. That would be one application. Alright, so let's keep that in our heads and see how we solve it. X is between 2 and 5, and we're talking about the square root of x plus 4. Alright, solution. Let's just note down the vital facts. Firstly, our function is that, and x, we are interested in the interval where x is between 2 and 5. Let's set up our integral. It's going to be volume equals pi. Our bounds are 5 and 2. And this is what we need to do. Dx. Is that hard to expand? I think not. The square root, well, if you square the square root of something, all you do is you remove the square root sign, isn't it? So it turns out to be rather easy. So what I'm going to allow you to do is time to finish that, and we'll compare answers in a minute or two. But really, that is all you are evaluating. Pi times that integral there. So we might pause it there.